Welcome to today's lecture on statistics and probability. Today we're going to look at sample space and the probability of an event. Let's begin by defining some of the statistical terms so that when they are referred to in your book or in your problems, you'll know what they're talking about. Then we'll look at some visual and numerical examples to help demonstrate how to find the sample space and the probability of an event. The first term word is outcome, and this is just the result of an experiment. So when we do an experiment, whatever our result is, we call that an outcome. The sample space is the set of all possible outcomes. So this is your total possible answers when we do an experiment, or the total number of results. That is all going to be considered your sample space. An event is any combination of outcomes. So usually when we do an experiment, we'll be able to subdivide it into smaller portions, and each of these things are called an event. Probability is the measure of how likely an outcome will occur. And a probability is always going to be a percentage, and it's going to, when we solve it, it will be a decimal and then we'll convert it to a percentage. So if we have a probability of 0, that means there's a 0% chance that it's going to happen, or another way of saying that is that there is no probability that it will occur, or it's never going to happen. Then at the other end is 100%, or when you do your fraction, it's going to be 1.00. So that means we have 100% chance that that probability is going to happen, or that outcome is going to occur. Most of your probabilities are going to be somewhere between 0 and 100%. And so then when you're doing your division and you're getting a decimal, it's going to be between 0 and 1. So it's going to, when you do your calculation, it's going to look like a decimal, then you'll convert that to a percentage. So the formula for finding the probability of an event is you're going to take the event and divide it by the sample space. So it's the outcome of the event divided by all possible outcomes. Now let's look at an example to help demonstrate what each of these words mean. So with our first experiment, we're going to flip a fair coin, and then we want to identify what is the sample space and the event probability. So if I have a fair coin, a coin has two sides. So that means if I'm going to flip it, I have two possible outcomes. I have the possibility of getting a heads or a possibility of getting a tails. These are going to be the results of our experiment. That means the sample space is also going to be 2 because it's the set of all possible outcomes. So the set of the sample space for flipping a fair coin is going to be heads and tails. Have 2 possible outcomes. An event is any combination of outcomes. Well, when I do my experiment, one event is going to be to get heads, and the other event is going to be to get tails. Each of those have one outcome each. So now the probability, or the measure of how likely an outcome will occur, we're going to determine that by finding the probability of each event. And so remember, that formula is event divided by sample space. So if I want to get the probability of obtaining a heads, I'm going to take the event, which is one head, divided by the sample space, which is a heads and a tail. That's going to be 1 divided by 2, which equals 0.5, which gives me a 50% probability of achieving a heads when I flip a fair coin. A tail is going to be the exact same. I have one possible outcome for getting a tails. I'm going to divide that by the 2 possible outcomes in my sample space. That gives me 1 divided by 2, which equals 0.5, which gives me a 50% probability of obtaining a tails when I flip a fair coin. Let's look at our next example. In a bag we have 1 green, 2 red, and 3 blue marbles. What is the sample space? So let's look at, we have 1 green, 2 red, and 3 blue marbles. So that means this is going to be, all of the marbles is going to be our sample space. And we can denote that by using the letter S. So whenever we do have a sample space, we use the letter S, and then we put it in brackets. So that's going to be 1 green, 2 red, and 3 blue. That is our sample space. And we have 6 possible outcomes from our experiment of drawing a marble out of a bag. So now let's look at the next thing. What is the probability of drawing each of the colored marbles? So you'll remember that to get the probability of an event, we take the event and we divide it by the sample space, or the number of outcomes in an event divided by the total number of outcomes in the sample space. So let's write the probability of events for each of these colors. So this first one is going to be the probability of drawing a green marble. I have 1 green marble in my bag, so I have 1 possible outcome for the green, and I'm going to divide it by the 6 total possible outcomes. When I do that division, it's going to give me a decimal of 0.16 with a repeating 6. When I convert that to a percentage by moving the decimal 2 digits, that's going to give me a 16.67%. That is my probability that when I draw a marble out of the bag, out of the 6 possible marbles that are in that bag, I have a 16.67% chance or probability of drawing a green one. Let's do the same thing for red. The probability of drawing a red marble, I have 2 marbles, so that's 2 possible outcomes for a red event divided by the 6 possible outcomes for drawing any of the marbles. That's going to simplify to 0.33. That repeats. So when I convert that to a percentage, that's going to be 33.34%. That is my probability for drawing a red marble out of the possible 6 marbles that are in the bag. And then the last one is going to be the blue. The probability of drawing a blue marble, I have 3 possible outcomes for a blue event divided by the 6 possible total outcomes, and that's going to simplify to 0.5, which means I have a 50% probability that if I am going to draw a marble out of the bag, that I'm going to have a 50% chance or a 50% likely outcome that I'm going to draw a blue marble. Now the last part of this question says, what is the probability of getting at least 1 red marble? Whenever your question asks you to do at least 1, it's asking you to do the same thing that we just wants to know out of all of the total possible outcomes, what is the probability that I am going to draw a red? So for this case, the probability of getting at least 1 red marble is the same probability as drawing the probability of the red marble event, which is going to be 2 over 6, which equals 33.34. Out of my 6 possible marbles, I have a probability of drawing at least one red marble 33.34% of the time. Let's look at our next example. In this example, we have a fair 6-sided die. And we want to know what is the sample space. So with the sample space, we write that as the letter S. We have a fair 6-sided die. Now you'll notice that with a die, each of the sides have a unique number. So the sample space is going to be number of dots on each side of that. 1, 2, 3, 4, 5, and 6. That makes up our sample space. Now the next question is, what is the probability of rolling each side of the die? So that's going to be the probability of rolling a 1, the probability of rolling a 2, the probability of rolling a 3, the probability of rolling a 4, the probability of rolling a 5, and the probability of rolling a 6. Those are all the sides of the die. Now, if you'll notice, each of these just occur once. And that's because for each side of the die, there is one possible outcome out of the 6 possible outcomes. And you'll notice that the probability for each side of the die is going to be exactly the same. So that's going to be 0.16 recurring, which is 16.67%. So each of these sides have a 16.67% chance of occurring when I roll my dice. So whenever you have a sample space and each item has an equal likelihood of occurring, then that means that the probability of each of your events are all going to be exactly the same. Now let's look at the next question. The next question says, what is the probability of rolling an odd number? What is the probability of rolling an even number? So now instead of looking at just an individual side of the dice, we are creating different events. We want to know what is the event odd and what is the event even. So the outcomes of the odd are 1, 2, and, the outcomes of the odd are 1, 3, and 5, and the outcomes of the even are 2, 4, and 6. So we now have the event odd and the event even. So if we want to get those probabilities, we're going to get the probability of the event odd, or getting the odd outcomes. We have 3 possible outcomes for rolling an odd number. We're going to divide that by the total number of possible outcomes, or our sample space. That's going to be 50%. We're going to do the same thing for the even. Once again, I've got 3 possible outcomes. I'm going to divide that by the total possible outcomes, and once again, that's going to give me 50%. So with this problem, I have a 50% chance of rolling an odd number and a 50% chance of rolling a even number. So our probability is 50-50 on whether or not we're going to roll an odd number or an even number. Now let's look at the next question. It says, what is the probability of getting a number greater than or equal to 4? So we want to know a number. This is a new event. A number that is going to be greater than or equal to 4. So this event space is going to have the outcomes of 4, 5, and 6. So to get the probability of the event of a number greater than or equal to 4, we've got 3 possible outcomes, the number 4, 5, and 6. And then we're going to divide it by the total number of possible outcomes, which is 6. So 3 divided by 6. Once again, that's going to give me a 50% probability or a 50% likelihood that I'm going to have an outcome of rolling a 4, 5, or 6. Let's look at the last one, which says, what is the probability of getting a 2 or a 6? So we're defining a new event of what is the probability that if I roll the dice that I am going to get a 2 or a 6. This has 2 possible outcomes, the 2 side and the 6 side. So when I get the probability of rolling a 2 or a 6, I'm going to take my 2 outcomes divided by the total 6 possible outcomes, which is going to give me 0.33 recurring, which is a 33.34%. So I have a 33.34% of rolling a 2 or a 6. So this shows you, this has been several examples of how to find the sample space and how to find the probability of an event. So just to reiterate, the sample space is going to be all of the possible outcomes. So when you do an experiment, all of the possible results, those are going to be in your sample space. To find the probability of an event, any event is just going to be like a subdivision or a specific type of outcome that we're looking for. And to find the probability that that's going to occur in our experiment, we're going to take the number of possible outcomes of that event and divide it by the total number of possible outcomes in our entire experiment, or the number of outcomes of the sample space. So that should cover everything you need to know. Thank you for watching. See the links below for additional supports and resources, and be sure to like and subscribe to get the latest videos from Caz Academy. Appreciate you watching the videos, and I'll look forward to seeing you at our next video. Thanks for watching.